Hello everybody and welcome to Azure Samurai. On this video we will be continuing the series of videos dedicated to Squadron and take a look at a bit more practical to what we saw in the concepts. We will be implementing one or two providers, very simple ones, and see how do they work and how the containers are created. We can catch it, that's it. So let's get to it. So let's get to it. We are creating a XUnit test project. We will give it a name like my first Squadron app. And click next. And I don't know, .NET 5, .NET 6, I think .NET 5 is okay. And then we create it, and we will go to create a couple of classes that we need. But before, we will check what NuGet packages do we have and add the ones that we may need now and in the future. So we need XUnit to be 2.41, that's correct, and 2.43, and then we will add Squadron Mongo and Squadron Redis. We will do this Quickstart with Squadron Redis only, but we will use Squadron Mongo later on in a future video that we will expand this demo. And Redis. We install it, latest and greatest, and accept everything as always. Updates. Oh yeah. Nah. Good upgrade, but we don't need. So let's skip it and create the first class that we need. We will create a Redis cache and we will store users. So we'll create a user here. Very simple one with some properties like ID. Yep. Yeah, email as well. I think that's it, and we will provide a default user with a function. Kind of a John Doe. Well, basically John Doe. X, known, and name John. Mail John Doe, yeah, why not, squadron.io. As well. Another one. This class is from Redis, so I need to add a Redis using, but we already have it. I'll show that in a moment. Come on. Yeah, system text.json, because we will need it in a moment. Yeah, nothing else. We will need here a connection. And to add the user, yeah, we will get the database. Obviously, we work for interfaces, as that's the way to go. Yeah, and come on, and then open and close brackets. And we do a string set here, and we serialize the user to store it. Okay, we use underscore users underscore and then the user ID as a key, and then we store the serialized user on it. And that's it. Next we go for the test. And here we will do something very interesting for MongoDB, which is we'll use the iClass fixture, which is used to decorate Xinit test classes and collections. So to add a test fixture data, an instance will be initialized just before the first test in the class is run. That, of course, it will implement properly iDisposable to be disposed after the test, and then this is what will generate the resources for us. In this case, this Redis resource that we are adding now the proper using. That's what will do the trick. We still need to do one thing. To resolve it, we will add a read-only property field here, resource, which type of Redis resource, and resolve on the constructor. That's all the wiring, and now we can write the test. On the test, we are going to create a user, we are going to add it to Redis, and then we will retrieve it and check that both are equal, well, equivalent in this case. That will do. We'll do here the usual arrange, act, and assert. So first arrange, and now we create the user with the method we created just a moment ago. Now we'll need a connection. So we can create a user cache repository in our Redis, which, as we explained before, it's in a container that it is created for every single test. We don't have connection multiplexer, so we have to add the reference to Redis, the stack exchange Redis. That will solve it. But this, I will show you where it comes from. So when we added the package, the Squadron Redis, it comes on it. So we can use it right away. And the repo, which is the user cache that we added with the connection. The range is done. Now we will act. Basically, it's adding the user to the repo. Repo add user, yeah. Could not be simpler. And on the answer, we retrieve the user and compare that the users are the same. So essentially, the user should be the user from the cache. This we need to do like a bit of a inverse thing of what we did before in the repo. The proper way would be to do that in repo, but yeah, just we add it here to save a bit of time, and we will move it later to the repo. So we get again the database, and instead of a string set, we do a string get with the key that we set up, underscore user underscore and the ID. And we get a JSON value here that obviously we will need to deserialize. There's a string get of the ID with underscore users underscore. Now we need to deserialize it, and then we need the JSON serializer that we will add it in a moment. Didn't add it. System text JSON. Yep. And now it's mostly done. No, to string. Yeah, parentheses. Come on, IntelliSense. Yeah, that should be it, and now we can execute the tests. Oh wait, yeah, we need to assert that they are equal, which say that the cache user should be equivalent to the user. And for that we are going to use a library which is pretty cool. Fluent assertions. Okay, didn't add it, so we will have to add it. Let's install it. that makes everything a lot more readable in your test. And also the test error becomes a lot more clear as well. So it does not only affect in the coding but also on the exception. It's pretty cool. So cache user should be equivalent to user. You read that, you understand that it's how a test should be, right? No, be equivalent. But pretty close. And we will run all tests. And yeah, let's bring the test explorer here and expand it, even it's just one test, but we'll move it to a side and bring Docker in so you can see what's happening. Should be right now. Some typo. Let's bring Docker. We have Redis, and now we will remove the Redis image. So you will see now how it is downloaded. Well, you will not see how it is. It will simply appear once we execute the test. After a while, of course. And here it is, the image is just loaded and it's in use and the test is finished. Now we'll see the same, the lifetime of the container as the test runs. So let's execute it. Now you will see how the, that was too fast. So let's do that again. Let's run the test. I have slowed it down a bit. So now you will see it's created, it's running, it exits, and it's moved. And that's it. So I hope this video was illustrative, and we will go a bit deeper on the next one. See you.